Hi, my name is Eamon Engber, and I am a fire ecologist with the National Park Service. Today I'm going to be talking about weather monitoring for prescribed fire. So with that, we will go ahead and get started. Just to give you a presentation outline for today, I'm going to be talking about pre-burn weather monitoring and some seasonality. So we'll hit on long-term trends in terms of drought, live fuel moisture, 1,000-hour fuel moisture, and some popular links you can use to assess some of this information. Then we'll get into some short-term trends, talk about monitoring 10-hour fuel moisture and fine dead fuel moisture, and then ultimately we'll get into burn day weather monitoring and look at some examples of calculating relative humidity, fine dead fuel moisture, and probability of ignition. And throughout the presentation, I'll be sharing some helpful links and tools so that you guys can have a good idea of where to get the weather and fuel moisture information that we need for monitoring prescribed fires. So in terms of pre-burn weather and fuels monitoring, the components that we need to be looking at throughout the season are going to vary depending on the fuel type and the primary fire carrier for your burn unit. Obviously, that makes a lot of sense. So, for example, you're really looking at two primary categories. If it's live vegetation, so either herbaceous fuels, grasses, forbs, or shrubs, those are going to be more dependent on phenology or the seasonal time frames of their growth and when they're going dormant and things like that, versus this photo in the middle is just a pretty blank understory dominated by woody fuels and leaf litter, and so those are going to be more dependent on just the antecedent weather conditions and time since rainfall and things like that, and not so much a seasonal growth cycle. So with that, let's talk about some long-term trends, and seasonality being the first factor, which is going to be relevant in terms of ongoing drought or live fuel moisture trends, 1,000-hour fuel moisture. If you're not familiar with the time lag classes for woody fuels, 1,000 hours are those dead sticks, logs, etc., on the surface of the forest floor that are 3 inches or more in diameter. So a site that is super useful that I like to get on frequently throughout fire season is the Northern California Geographic Area Coordination Center, and go to the Predictive Services page. So this is based out of Redding, California. It's an interagency center for the fire agencies. And if you go to the Predictive Services page, you can click on the fuels and fire danger. And on that page, there's a number of links to useful fire danger metrics. So for one, there's typical fire danger rating metrics, so things like energy release component, burning index, and then they also have 1,000-hour fuel moisture and other size classes of fuels that you can look at. And this is based on the network of remote automated weather stations. But you can click on any of those and it'll pop up the current chart for each one of those categories, and you can see an average value and where you're currently at in the season. So just a good idea for being able to look at seasonal trends in fire danger and fuel moisture. Honing in on a couple of the other links on this page, there are some links under the Wildland Fire Assessment System, and there you can look at observed fire danger throughout the U.S., relative humidity, other indices. And then there's also a link to the National Fuel Moisture Database, and that's a pretty useful page for those larger fuel diameters, and I'm going to be showing that shortly. Also on the Predictive Services page, there is a weather page. So if you click on the weather page, there are some useful discussions of fire danger. So they have these hourly fire danger maps, 2-day outlooks, the North Ops outlook, but their seasonal outlooks are really good, and they're issued once a month, and they've got a discussion of fuels and previous weather, snowpack, and associated wildland fire risks. So those are just good things to pay attention to throughout the season as these products are released to keep you in sync with what's going on weather-wise. There's some other links on here to RAWS pages, so you can actually look up an individual RAWS station from here. You can go to National Weather Service offices and look at their current weather maps. All those GAC products are listed here. Those four-month outlooks are pretty good. They're updated the first of each month. There's some webcasts they have. So just a bunch of useful links here to click around on. They also have snow and precipitation data. So trying to look at where we're at seasonally in the state, snowpack in terms of percent normal, climatology and drought. So you can go to the Climate Prediction Center. There's a ton of links on here. So you can kill a lot of time looking at weather and fire danger on this predictive services page. This is a screenshot of their seasonal outlook, and these are issued the first of the month, and they just give some highlights about precipitation trends, weather, temperature, snowpack, and then significant fire potential. And so that's a good thing to be taking a look at as you hone in or get closer to your prescribed fire seasons. So still on this long-term trends topic, I mentioned the National Fuel Moisture Database in the last slide, and that's under that Wildland Fire Assessment System. And if you look at the National Fuel Moisture Database, this is the website address on the upper left here, and when you go to the page, it'll show a map with all the different sampled fuel moisture sites. So there's usually going to be a site close to you if you're in the Northern California region. And what I'm showing on the right here are a couple charts that you can look up once you click on these. And these are for Mad River. And so it's mostly live fuel moisture data that's collected. There's also 1,000-hour fuel moistures. And so you can find the site that's closest to you and look at the trends in those fuel categories. And so sometimes there's holes in these data sets. They're not perfect. These are wildland fire personnel who are primarily collecting these data. And if it's a really busy fire season, you'll start seeing some holes. But hopefully the current year is being sampled, and so you'll see current year values, the average, and the low values. And for example, this shows Manzanita on the right on the Mad River Ranger District of Six Rivers National Forest. And you can see that the general trend is it starts out pretty low in mid-April or May. That's pre-green up, so that's just winter dormancy coming off of that. Start to grow and turn green and green up in June, peak mid-June or July, depending on the year. And then in August and September, it gets down into that trough, the low point, and doesn't really recover all that much until the next growing season. On the bottom, you can see the Mad River 1,000-hour fuel moisture, and so these are 1,000-hour logs where cookies are actually cut, so these aren't modeled like from the raw stations. These are actual values from samples that are taken and dried in an oven. But again, these give you an idea of the long-term trends and then where you're sitting in the current year relative to past years in terms of drought and dryness related to fuel moisture. So another thing to be paying attention to that's a really great resource for everyone is these RAWS weather stations, so remote automated weather stations, and I show the web address on top here. And so what you have to do when you navigate to this page is make sure when you hit network here, I think the standard is it'll be on National Weather Service station networks, which are also good to look at, but I like to take a look at the remote automated weather stations. And so put it on RAWS, hit refresh map right here, and then you can find the nearest station, not necessarily the nearest station to your site, but a station that's in a representative landscape position and fuel type. That's what you want to find. It's relatively nearby. These are remote automated weather stations that collect hourly weather data. And so you can look at current conditions. So this is a Neyland station I pulled up, and just what pops up when you click on a station. So it'll give you the 24-hour maximum and minimums, current weather conditions. You can look at a windrows for the site, which gives you the proportion of winds by magnitude and direction. You can look at these graphs that show here the trends in temperature and dew point and relative humidity. And then the cool thing is you can also look at past data if you want to look at precipitation or see some of the trends leading up to when you're thinking about getting into your prescribed fire season. So these weather stations are really useful, and I pay pretty close attention to them when we're getting close to burning, because if you've got one nearby, it's going to be a really good source for you. So on this topic of shorter term trends, I like to not only just look at the National Weather Service products, but you can go to the National Weather Service Fire Weather Forecast page, and here's the address for the Eureka Fire Weather page. And so under NWS, they've divided regions into fire weather zones. And so you can figure out which zone you occur on, and then you just click on this map on your zone, and that will pull up a fire weather forecast that's pretty specific in terms of the metrics you want to understand for fire weather and fire behavior. So that's why I like these fire weather zone maps, and they'll also show any areas of red flag warning or fire weather watch on the map when you pull it up. But just as an example, so it'll show today the sky weather, the max temperatures, the minimum humidities, and the winds for valleys versus ridges. So some of the key information you need to know, which is helpful. You can get some of this stuff from the general forecast, but this is a little bit more specific to fire weather, and it's geographically located to those zones, which is good. So another tool I like to look at in terms of assessing short-term trends leading up to prescribed fires, and this is 10-hour fuel moisture sticks. These are one of the components that I like to see in a burn prescription. They're pretty useful, but they're great indicators of fuel moisture for forest understory conditions. Generally, a range of around 8 to 13% will carry fire pretty well in oak woodlands if you're managing fire in oak woodlands in Northern California. But these 10-hour fuel sticks are standardized half-inch ponderosa pine dowels. They weigh 100 grams. And so you put them out in the woods on these little racks, and you can go out and weigh these, and you just look at how much they weigh relative to their known dry weight of 100 grams, and that gives you the percent fuel moisture. So if they weigh 110, you know they're 10% fuel moisture. So you can weigh them in the field. They're available from vendors online. I think places like Forestry Suppliers and Ben Meadows carry them. There's a little field scale you can get to weigh them in the field. But these things so they're in that 10-hour time lag class, so a quarter to a half-inch diameter. And that's approximately the response time in terms of changing atmospheric conditions and how quickly those fuels will respond. So I think of them with about a daily response time. So you can go out, and I like to put them out a couple weeks before I'm thinking about burning, and maybe assess them every few days or so. But they're just really good. They're constantly reacting to changes in atmospheric conditions in terms of temperature, humidity, and pressure. So it's really helpful to know where these things are at. And like I said, once you're getting down around that 8 to 10 or 8 to 13% or so, that's generally a window I like to start looking at in terms of prescribed fire. But it's going to depend on your burn plan and your fuel conditions and all the other factors that go into developing a prescription. So other factors we look at in terms of your typical prescribed fire prescription would be relative humidity, or RH, temperature, POI, that's the probability of ignition, 10-hour fuel sticks, we mentioned that, wind. And what I want to go through for the remainder of this presentation is how to calculate the RH and the POI, if you're not familiar with that. So there's two primary methods. So on the left, I have a picture of a Kestrel 5500 Fire Weather Pro. So this is a little handheld weather meter of sorts, and it will give you the relative humidity, the temperature, the wind, and also some of these more fire behavior or fuel-centric metrics, which would be fine dead fuel moisture and probability of ignition. And you can also get them with a little tripod and put them out in the field throughout the season, and they can data log. And they're pretty handy because there's a Kestrel app you can get for your smartphone and Bluetooth data transfer in the field, and it'll plot it out for you, all your trends. So it's pretty cool. They're fairly accurate. The gold standard, though, however, for weather monitoring is the Sling psychrometer. You want to have a new one in good shape that's clean, be accurate. I'd say these days Sling psychrometers are still weighed on a little more heavily than Kestrels, but lots of folks are using Kestrels. I use them pretty frequently in my work, and you just got to make sure your Kestrel's calibrated and in good condition. And you can do that by comparing the two. maybe at the beginning of each season, run a weather with a sling psychrometer and use your Kestrel and make sure it's calibrated. But the Kestrel is simple and fast and easy. There's some settings you need to be aware of on there. But we're going to go through the sling psychrometer and relative humidity tables and find dead fuel moisture and probability of ignition, just to go through that process. So if you don't have a Kestrel, you got a sling psychrometer. I've put the instructions for sling psychrometer use on here. I'm not going to read all of these, but there are specific instructions you need to follow when you're using that sling to make sure you get an accurate reading. And so make sure you read those. Step one, though, is to get your sling, and then you also need to print out or have available these relative humidity tables. And so I've put a link here to PMS 437, which has RH tables printed in it. So these relative humidity tables are what you use once you use your sling psychrometer and you get a dry bulb and a wet bulb reading. Then you can look up those values and figure out what your dew point and your relative humidity values are. So once you've utilized your sling psychrometer and you have a dry bulb and a wet bulb, then you go to the correct RH table for your elevation. So make sure you look at that first. That's on the top here. On the left side of these charts is the dry bulb temperature, and on the right side is the wet bulb temperature. And so what you do is, for example, say you get a dry bulb of 60 degrees Fahrenheit and a wet bulb of 46. Then you can go down to the 60 at the bottom left here, scroll over, find where that 46 column intersects your 60, and the blue on top is dew point, and the red on the bottom is relative humidity, and that's 33%. So it's pretty straightforward using the tables. The main thing is just making sure you have the correct tables printed out for your elevation. These tables continue, so if you're above 60 degrees, you can keep going down to 80, and they keep going. You just got to print them out and make sure you have the range for the conditions that you're going to be working in. So once you have the relative humidity, the next step is to calculate the fine dead fuel moisture. And so fine dead fuel moisture relates to the fuel moisture of 1 hour fuels, so fine fuels that are less than 1/4 inch diameter. You can think your dead grasses, your small sticks, your leaves and twigs. And you need to calculate the fine dead fuel moisture because that's the next step in calculating the probability of ignition, which I'll talk about next. So for fine dead fuel moisture, the first step is to find your reference fuel moisture. These are broken down into a daytime reference fuel moisture and a nighttime reference fuel moisture table, so make sure you're in the right one, depending on your time of day. I have the daytime fuel moisture table here. And so we'll continue with our same example. So once you find the correct reference fuel moisture table, we'll use those values of a 60 degrees Fahrenheit for our temperature and an RH we calculated of 33%. So if you go to the table and you can see it's dry bulb temperature on the left, and on the top we have the relative humidity ranges. And so we can look at the 50 to 69 temperature, that's the row we want to be in. And then we go over to our humidity, which is 33%, and we see that our reference fuel moisture is 5%. So you want to record that 5%, and then the next step is we adjust that for the time of year and time of day, the aspect of your site, and the fuel shading. So for step 3, we're going to calculate dead fuel moisture correction based on those factors. We're going to read the value from the table, and then what you're going to do is add the correction value to that reference fuel moisture, and that is your final dead fuel moisture content. So these fuel moisture correction tables are broken up into different months. So you need to make sure you're on the table that is for the range of months listed here. So for example, this one is May, June, and July. Down here is November, December, January, and over here is February, March, April, August, September, October. So let's say it's November. let's say the site is unshaded, and shaded versus unshaded is 50%. That's the cutoff, so 50% canopy cover, 50% shade. We'll say it's 11 o'clock, and we're on a west aspect and on a slope that's less than 30%, and we're at the elevation that our burn unit is at. And so what we're going to do is go through the process of figuring out that fuel moisture correction value. So let's see, it's November, so we're going to be on this table. If you look at the top portion of this graph, these are for exposed, so unshaded. So you use all of these here, they're yellow. If it's shaded, you use these gray tables. So we said it's unshaded, and then we said that we're on a west aspect, so you down here to the W, so we're going to be in these rows right here for west aspect. We said that it's less than 30% slope, so we're in the 0 to 30% row right here. And let's see, the time of day is 1100 hours. So if we look at these are in 2-hour increments, so 1000 and 1100 are going to be in here. We're going to be on this level column because that means we're level with the site that we're interested in weather information for. And so you can see that the fuel moisture correction is 4 based on that 0 to 30% slope, the exposed fuels, and the level observation point with your burn unit, and the 1000 to 1200 time period. So once you get that fuel moisture correction value, you add that, which is 4 here, to that reference fuel moisture, which was 5, and that is your fine dead fuel moisture of 9%. And so that's how you calculate the fine dead fuel moisture. Just once you run through this a few times, it becomes pretty straightforward. You just have to make sure you have all the information you need, and that'll hone you in on the correct table, the correct column, and the correct row. So our fine dead fuel moisture is 9%. The next step is to calculate the probability of ignition. Now, probability of ignition is a pretty cool metric because it gives you an idea of how flammable or how receptive your fuels are to burning. And so typically in prescribed fire, people, at least in Northwestern California where I've done most of my burning, you might be working with a probability of ignition between 30 and 50%, say. Once you're above about 60% probability of ignition, that means more than half of your embers that are landing on a fuel bed are likely going to ignite and spread. And so typically we're not lighting prescribed fires in the high ranges of probability of ignition. That's more typical of wildfire scenarios. So to calculate the probability of ignition, you can use your fine dead fuel moisture, the temperature, and the shaded versus unshaded status of your fuel bed to calculate those metrics. So for example, we'll run with that same temperature of 60 degrees. We'll say our canopy cover is less than 50%, so we're unshaded, and our fine dead fuel moisture is 9%. And so if we look at the table, you can see it's got fine dead fuel moisture here on the top, dry bulb temperature ranges here, and percent shading. So it's split up into this unshaded portion on top, and then the lower half is the shaded portion. So make sure you end up in the right set of rows. So if you go to unshaded, dry bulb temperature, 60 degrees, so we're right here, and our fine dead fuel moisture was 9%. So that puts our probability of ignition at 30%. And that is how you calculate the probability of ignition. So that's doing it the old school method, running through the tables. There are some digital versions of those tables that can speed up the process. One application that I like to use is the Wildland Toolkit. It's not free. There may be other apps out there that do this for you. I'm not personally tied to this software in any way, but it is pretty useful, and you can type in your relative humidity and temperature, and it can calculate fine dead fuel moisture, probability of ignition, and it also will do a lot of fire behavior calculations if you're interested in that. But it's pretty quick and easy to plug it in there. And again, if you have the Kestrel, it does all of that for you once you create the settings on there. So the date's got to be right, the time, and the shading, and things like that. But the old school method is to go through the tables, and it's good to do that just to ensure you understand the process. The next thing I want to discuss is just documentation. This is a form that I like to use for on-site weather observations. So it has rows for time, location, elevation, the aspect, the dry bulb temperature, the wet bulb temperature, and then when you do your calculations, you'll get RH. It has rows or columns for wind speed and direction, cloud cover, percent shading, fine dead fuel moisture, and probability of ignition. So this is the standard wildland fire module weather observation form, and it's important to document your conditions. You know, for one, recording observations allows you to build knowledge of your prescriptions and the associated fire behavior and fire effects that you see with those prescriptions. By documenting, it allows you to improve those prescriptions and adapt, and really to be a student of fire. So I just can't recommend it more, that it would behoove them to well document the conditions leading up to prescribed burns, and record those and log them so that next year when you come back, you've got that. So that's the end of the presentation. Hope you enjoyed it, learned something, and that's all I got.